Hey everyone, welcome back. So last week we did not have a new lab video because there was a lot of other stuff you guys needed to work on, like the first exam, the first lab assignment was due, and you were also revising your project idea, which you might still be doing. But this week we have a new unit, so in the textbook we're covering Unit 3, lessons 12 through 15. So in this tutorial, we're going to build on the skills you learned in the last unit. Before, we worked on creating, editing, exporting, and validating the data sets, which is, good to start with. But in this unit, we'll focus on managing data so that it's easier to analyze. That includes finding things, recoding variables, computing values, sorting, ranking, and even splitting and merging files. So some of these steps, similar to last time, will be practice only, while others will count for points in your assignment. So I'll just make sure which ones are graded are clear. And I've detailed this in our lab assignment here as well. So under assignments or under modules, if you go to lab assignments, and it's all detailed here. What is graded versus, not graded practice, and then what you ultimately need to submit. So be sure you pay attention to this. I had some questions this past lab assignment about submitting screenshots. I don't want screenshots. We want the full data files, output files, whatever it may be, to grade. Screenshots, can be a quick way to verify that something is there, but it just leads to even more files that to download and work through, more files for you to upload usually. So the full data files, usually I can verify several steps just with that one download. So be sure to just pay attention on what to submit there. Okay, so getting started. I'm working in the same data file we used for our last assignment, so lesson 7. A lot of my instructions are going to be based on these variables, so I recommend reopening this data set, but I guess in theory you could work in a different data set if that worked for you. But a lot of the variables I'm going to reference are going to be and I'm going to complete the steps using our original data set that we created. Obviously not any real data, but yeah, so if you can reopen this, but if you work in a different data set, that's totally fine. If you complete the same steps, I will still be able to verify that you did the steps correctly. So just something to note there. So in this, fabricated data set, that's not based on anything real, any real student data or anything like that. It's obviously very small, so we only have a few variables here. But when working in research and data, sometimes you have a very large data set with dozens of variables, so a ton of these variables, hundreds if not thousands of cases, depending on how big your sample is. So sometimes finding things is not as simple as, these 5 variables we have here, 5 or 6 from the last assignment. So, obviously when I scroll down here, there's nothing over here, but sometimes you'll be scrolling for a long time. This bar will shrink and it will be a really massive data set. So that's why this one's just practice, because like I said, I don't have a large data set for you guys, but just to practice going through the motions of finding variables, like the steps you would need to do if you didn't want to scroll all the way through a really big data set. So yeah, finding variables. Let's say you have dozens of variables and you want to be able to find one quickly. You would go to utilities up here and then variables. And then here you could just select what you want to go to variable. Like I said, in a small data set, it's not it's not as impressive, but just so you know, that's how you would do that function. You can also find a specific case, so a specific participant ID. So here you would go to Edit, go to case, say you want to go to case 8, go. And it takes you right there. Like I said, 10 participants is not a lot to get through, so it's not a big deal, but just so you know how to do that. Again, we went to edit, go to case. You can also find a specific value. So say we're interested in finding a specific value in our test 2 scores. Again, not super overwhelming here, but could be easily hard to find with hundreds of participants to scroll through. So I've highlighted the variable I'm interested in, go to edit, find, say I want to find 87. It found it for me. So I am not interested in replacing, but that's also what I would do. Like, this is also where I would go if I need to find and replace. So great. These steps are just practice. Again, they don't leave any sort of trace in your data, so they aren't graded. But anytime you're working with large data sets, those can save you a lot of time. Now, on to lesson 13. So this is about, recoding and computing values. So we want to learn how to transform raw data into more useful variables. And this is going to really depend on what variables you're looking into, how your study was set up, and how you're doing your analyses. So it really depends. But sometimes we want to recode the values that we assigned a variable. So think about those categorical variables that we assign numbers to. This can sometimes come in handy, or other variables like maybe not gender in this case, but maybe if we had a variable on like income or something like that. And maybe we, or even like scaled variables, sometimes we'll have reverse coded items randomly thrown into a survey. So for example, say we have a scale that has like a lot of different items. So all the different items would be their own, maybe a variable in our data set. So maybe we had a stress scale and it was like the first stress item is one variable, second stress item. Maybe we want to take the entire like stress scale, so all of the items in our stress scale, and create an average. So we have like a composite stress score. So that has to do with computing our new variable, so using like a formula, which we'll get into in a little bit. But sometimes with these scales, we throw in an item that is maybe like reverse coded. So maybe all of the items, so for example, test scores here, all of these test scores are on a range from 0 to 100. So 0 is the minimum score, 100 is the maximum score, and we know that lower test score values are associated with like lower test scores, which sounds intuitive. It sounds obvious, right? And higher test scores are associated with, a higher score in the class overall, like achieving a higher, better score. We know what that means. Let's say for whatever reason that one of those scales was flipped. So maybe a 0 was the highest possible score, something like that. Obviously, that doesn't intuitively apply to test scores. Like the higher scores are always going to signify scoring a higher score on the test, meaning getting more questions right. So that makes sense that way. But sometimes there are scale items that we use, like I said, a stress scale or any type of scale where we have a reverse coded item, where maybe for one specific item in the scale, so say the second item in this scale would be reverse coded, where 0 would actually be the high score and 100 would be the low score. And the reason that this happens sometimes, like I said, not with real test scores in a class, but whenever we're doing like a research survey or something like that, sometimes we throw in a reverse coded item to ensure someone is paying attention. Essentially, if you ask someone, oh, how stressed are you? And they rate it a 10, Then if you ask them the next question, how relaxed are you, you would expect not a 10, but like a 0 or 1, like a lower score. And that is kind of the best example I can think of for why we would have a reverse coded item in there. It works as like a sort of attention check, a bot check, to make sure that someone is paying attention to the items that they're reading and not just straight lining or reporting the same score for every single item regardless of the meaning. Because in research, we don't want, obviously with test scores this is different. This is like a test score that they scored on a test, not just like a self-report item. So I would say reverse coded items are very, very common with anything self-report in research, because we want to be sure the data that someone is reporting is at least accurate in terms of what they believe to be their stress levels, or the inverse, how relaxed they are. We want to have a way to know that those scores mean something, at least to the participant, not that they were just putting in random scores or not paying attention. So essentially we will throw in a reverse scored item within a scale to verify that someone was paying attention. So if they scored high on when being asked how stressed are you, then if you ask them like how basically not stressed are you, how relaxed do you feel, or how much free time do you have, it depends on the scale, but there are ways that you can reword a scale item so that basically the scale anchors the 0 and 7 or the 0 and 10, whatever the maximum scale score is. Most Likert scales are 1 to 7. So yeah, in this case, it would be 0 to 100 for these test scores. But again, there's no logical reason we would have like a reverse scored test score, since this is just applying to the score that a student got on a test. So how many correct items they had, basically. So yeah. Essentially, we want to weigh, if we're computing a variable that represents like the overall test score, whether that's like a sum or an average, we would do the same things for items on a scale for like stress. So say we had 10 items on a scale and we want to come up with a composite stress score. Either we can add all of their items together to come up with a total stress score. So if it was like on a scale of 1 to 7 and there were 10 items, you could have like a maximum score of 70 on the total stress scale. So you would know 70 is the maximum score that someone can have. That would be like the absolute highest possible stress score someone can have if you're adding up 10 stress items that have the max score of 7. But if you have a reverse scored or reverse coded item in that scale, you don't want to just immediately total all of the items or all of the scale items up. You want to be sure you recode the reverse coded item so that it reflects. So basically that someone reported maybe a 7 on the reverse coded item, which really was a 7, reporting a 7 for being relaxed, doesn't contribute to a higher stress score. So that would actually be a lower stress score for that item. So you want to make sure that your total or even your average score, so say you don't even want a total summed score for stress, maybe you want an average. So basically the average value for across all of the stress items, but you want to make sure that your reverse coded items or your items that were, like the scale anchors were swapped, or they mean something different for those items when you're averaging or summing a stress score. The item that asked about, how relaxed do you feel, higher scores would not contribute to higher stress. Higher scores on that item actually contribute to lower stress. So hopefully that makes sense, but essentially there are reasons why sometimes you have a reverse coded item thrown in there. In this case, I'm going to recode gender for the sake of this assignment. So there are two things that you can do when you're recoding a variable. You can recode into a different variable, so create a new variable with the new values, or you can recode into the same variable. And I can show you where those options are. So here we have the option to recode into the same variable. So you see I have the variable of interest selected, or you can recode into a different variable. And almost always, like, there is pretty much no instance where it's like formally recommended to do this. I mean, there are some cases where it applies, where maybe it's something very straightforward. You don't need, say something was mistakenly done. Best practice is to usually just recode into a different variable. So maybe when initially setting up the study, you coded when setting up like the data, the variables like we did in the last one, the different coded values for gender. So say originally you thought 0 was male and 1 was female, and say you got that swapped from like how you really want to do it. For whatever reason, gender in this term, in this case, is arbitrary, so it doesn't matter which one is 0 and 1, but there could be other variables at different times where the specific value does matter. But in any case, say you just want to switch how you're recoding it, and you don't need, like, basically you don't need to be able to go back to this to like confirm how you had it the first time. Again, I always recommend recoding into a different variable. That is just almost always the best and safest practice when you're recoding. If you're doing those scale items, like I said, for a stress scale, and you were recoding, like I said, I think it's best to keep the way it's originally coded and then just create a new variable with a new name, like stress item 2, RC, reverse coded, is one example. But I will show you how to do both, but just know that recoding into a different variable is always what's recommended, because say, so when you go to do this, essentially you're putting in, this is the variable I want to recode, so I just selected gender, and then here is where we're going to name the new variable, so gender 2. Or you can do gender recode if that's like something you preferred. Like any sort of way to make sure you know that this is the new variable, this is what you recoded, maybe this is the one you want to use in your analysis. So again, it'll just create a new variable recoding these values, and you have to name it something different if you remember, because SPSS will not let you name it the same variable. So if I try to, so say I just did gender, you cannot have it under the same name. So now I have this ready, and I'm just going to define my old and new values. And for this one, it's we used a binary code, so there's only 2 values, so it's pretty straightforward. We're just swapping. So our old value was 0, and we want our new value to be 1. And we add. And then our old value is 1, and we want that old value to now be coded as 0. Add. So we're literally just swapping those two. With scale items, and it can get a little bit more tricky. So again, this doesn't apply to our gender variable right now, but say we're on a 7-item scale, it would look something more like this. I'm just showing you this for the sake of showing how complicated it can get. But say it's one of those cases where we now want, again, the high items on a scale to now recode as the lower scale anchor, sorry, and vice versa. So again, going back to that stress scale example. So if we had a stress scale where typically the items were 1 would be lower stress, 7 would be higher stress on that scale, but then we had a reverse coded item in there where we asked, how relaxed are you feeling? That would mean that now the higher scores, if a participant reported a higher score, that should now be an actually low stress score, and vice versa. A low score on being asked if you're relaxed should actually mean a higher score on the stress scale. So we would need to do values 1 through 7 and just basically swap those values. So now a 1 would be a 7, so the lowest would be the highest, 2 would be a 6, 3 would be a 5, 4 would still be a 4, 5 would be a 3, 6 would be a 2, and 7 would be a 1. So again, this doesn't apply to our current example because we just have gender, which is, 2 values, 0 and 1. But I just wanted to show you this is what it would look like. And this is why sometimes it's highly recommended to recode into a different variable, because at least you can, go back to the original variable and confirm that you did it right. Like I said, usually what I do here when I'm doing this is I just make sure I'm counting all the way through the scale. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7 to make sure I have all values accounted for and in order. So again, the more you do this, the more familiar you get with it, but recoding into a different variable just ensures that you can go back and say, oh, I accidentally made a mistake or something didn't recode properly, and I always have the original variable to go back to redo my recoding process if I messed up. When you recode into the same variable, the original data is lost. So basically the original input value coming from your data file is lost after you recode into the same variable, which is why it's highly recommended to recode into a different variable. There is no limit on the amount of variables that you create in SPSS, so it's always recommended to just add a new variable, name it something different. Maybe if you messed up on recoding a variable, delete the one that you know is incorrect after you figure that out. But essentially, I always recommend recoding into a different variable. So I'm going to remove all of these because this was just an example. So again, what we really want to do with this gender variable is change our coded value from 0 to 1 and 1 to 0. I'm going to hit continue. And okay. So pulled up my output file. So the recoding into a different variable is documented in your output file, and I come back to the data set, and now I have a new variable here. So what this did basically is, for some reason, say there was a mistake when we were originally coding our values, or maybe I look back at the way the survey was programmed and I see, oh, actually I had, originally 0 was men and 1 was women. And maybe in my survey, like in my original survey programming, I see that I actually had it defined the opposite way. So I just wanted to switch those. So now a 1 is for men, 0 is for women. Okay. So again, totally made up data. None of this really happened, but if you ever needed to recode, that's how you would do it. So how to recode into the same variable. So you go to transform, recode into the same variable, and it is the same exact process. The only thing that's different is that it just changes your values in the same variable that already existed. So no new variable will be created here, but it's the exact same process. So you don't have to create a new name or label your new variable. You just define the values and it will recode those values. So that this would show up as a 1, this would show up as a 0, 1, 1, 1, so on and so forth. Which is why, again, it's a bit dangerous because there is then no trace of what the original, you could go back here and you would have documentation that you recoded into the same variable. So in theory, you could use that, but it's just really easy to make a mistake that way and lose something. Okay, so next we want to work on computing a variable. So say we want to use these 3 test scores to create a composite test score or an average test score. I'm going to show you how to do both. I think in this case with test scores, what makes the most sense is an average. But there may be some cases where you want to do a sum score. So I'm going to show you how to do both. You can pick whichever one you feel like. So basically, I'm interested in creating a total composite or average score for my test scores across my 3 tests. So I'm going to go to Transform, Compute. So now I need to create my new variable. So what do I want to call it? So maybe I just want an overall test variable and I labeled it so I know later it's an average test score. Since I've worked in SPSS before, is I can just type in the formula I want, and then I need to pull my variables of interest over here. So for mean, I can just type in mean in all caps and then in parentheses move over my variables that I want. So now I have my test score for my average test score for each person based on their first 3 scores. Okay, another way you can do this if you don't want to type in the formula yourself, or I guess type all of it in yourself, would be, again, you're gonna set up what you want your new variable to be, and then you can also come under these function groups and, I'm just under all, but you can search by a specific type of function. But then I just come down here and I'm looking for me. And that it really just does the same thing for me. So now I just pull those variables over. Make sure to get rid of the question marks. So to me, just typing in myself, but if you just were unsure and wanted to be sure you're bringing over the right formula, you can select from the list here. Okay, so we already did our mean variable, so we already have that, but I just wanted to show you that you can select from the list. But another one we can do is sum. So where it is. So similar to this, we could do sum, and then in parentheses, just make sure we put in each variable. Or another thing you can do is make sure I change my variable. Another thing you can do is just type in the formula yourself. So plus. And that also created a sum for me. So like I said, you can use the sum, like writing out SUM in all caps before the parentheses, and then just put in your variables separated by commas, or you can use the actual plus sign. SPSS will pick up the formula either way, if that makes sense. So now we have 2 computed variables. Like I said, you just need one, so pick either, to average the test scores or sum the test scores, whichever you prefer. And that'll be your new variable. As long as you save your data set, I'll be able to see that you created that. It also shows up in the output, what I did. So I have the mean, and it shows you the exact formula, which is helpful too, and how I created the sum. And similar with how we did the sum, you could also just type in the formula for creating an average. So I could have done test 1 plus test 2 plus test 3, all in parentheses, divided by 3. So the total number of variables we have. But just typing in mean will automatically do that for you. So it's a bit quicker. Okay, so moving on to our next lesson. So we just want to, so this has to do with sorting and ranking. So we want to reorder and assign relative ranks. So basically what you'll be graded on here is sorting cases by a variable and saving your data set so that I can see that you sorted that way. So right now you can see you could consider this sorted by case. So it's going in ascending order of case or participant ID. So just 1 through 10 there is going in ascending order. Maybe, and again, there might be, you're almost always want to sort by your ID number. There are certain like cases where maybe you're interested in sorting maybe while you're like cleaning your data to quickly find the low and high values. Maybe you have a measure for like time spent on tests or something like. So say you had a variable for time duration of tests, or like the time that specific student took to take a test. And maybe you were looking for extreme like speeders, people who took like really like not that long, say if they were like an outlier or something in terms of maybe they weren't taking the test seriously or just like completely running through. Maybe you don't want to count their test scores in the data or something like that. Or you just want to see what is my minimum value. And so maybe you want the data sorted that way. So if someone took like 5 minutes on a test, you would know you want to throw their data out. Or maybe you're just interested in what scores they got, so on and so forth. But say you want to sort by your test score. Or in this case, since we don't have like a time on test, we'll just sort by the test score. But just know that there's not a real reason that maybe you're almost always going to want to sort by ID number. So I'm just saying practically, I don't know a situation where I would sort by test score and like save my data set that way. But just so we can practice and ensure you know how to do it, you can just pick one of the test score variables and sort the cases by a variable and save your data set. So how you do this is very simple. So I have my variable of interest selected. I'm going to data and then sort cases is up here. So again, usually I have it sorted by participant ID, but say I want to sort by test score 1, sort in ascending order. You can also sort in descending order if you were interested in the highest scores showed first. So, okay. So now I can see that my data set is resorted, so not by case this time. So it's in all different order here, but it goes from the lowest test score to the highest. And say you're working with your data and you're like, oh, I actually, okay, I got what I needed. Maybe I know now who scored the lowest and I can look at their other scores or whatever else I was interested in. But now I want my data set back to normal. So I will go to data, sort cases, and I can just redo that. Now it's back to normal. But again, for the purpose of this assignment, you will want to submit your data file saved with a different variable, sorted by a different variable, just so I can see that you did it, because I know that all of you are going to have it sorted like this. So what I want to do to confirm that you tried out this sort cases is sort by a different variable. So again, we're going to redo this. And then, so you can see the lowest scores are up here, and then I'm just going to save it like that. So now when I reopen it, I can see that it's sorted by ascending order for this first test score. So if you feel the need to make a comment and let me know which variable you sorted by, that's fine, but I'll probably be able to figure it out once I see that your ID numbers are no longer in order. Our last lesson for this assignment is basically splitting and merging files. So you're going to learn to analyze data by groups and combine data sets. So for this case, so we're splitting the file. So essentially what we do for splitting the file is pick our grouping variable. So you could pick, I'm going to pick our original gender variable. We just use this as a, opportunity to show you how to recode into a different variable. But this is our original gender variable, so I'm going to go with this. We also have our appropriate labels here, and I'm going to show you why this is good to have when you're splitting the file as well. Again, we did this in our last assignment, and I showed you how to code a specific variable as your different categories, so they don't necessarily associate with the specific number that you assigned, but just making sure you labeled them. And I'm going to show you why that's really helpful. So maybe let's actually start with splitting the file by this gender variable. So our recoded gender variable, which I haven't added labels to yet. So the reason that that's problematic, so not adding labels, is when I go to split the file. So typically when you go to split file, so it's under data, split file down here, it's going to have analyze all cases. So this is letting you know that you have not split the file. You're not splitting the file by any groups. So you want to check this down here, organize output by groups. So I already have this over here, but say you would move your recoded gender variable over here, sort the file by grouping variables is correct. You want that selected. So I'm going to hit OK. When I do this, so we can see I split the file. That's evident in our output, but I need to run an analysis to demonstrate how the output looks different, because the reason we usually want to split the file is we want to organize our output automatically by our grouping variables. So essentially when we run an analysis, we get separate output tables for the different groups in this grouping variable. So in this case would be you get one output table for men, one for women, which is helpful to have it already pre-broken up like that. So in some cases when you want that, that's very useful. So I'm going to go to Analyze, Descriptives again. And see, I already have test scores over here, so you don't need to do all of them. So say I just want to do maybe my computed test score variables, so average and sum. So you can just pick whichever one you went with. And descriptives is just, going to give you your basic descriptive statistics for these variables. And because we split the file, it's going to give our descriptives grouped by gender, our recoded gender variable. But you're going to get descriptives on these variables specifically, just grouped by men and women. And you can go to options and see the different options for descriptives. We're not looking for anything specific here for this assignment, so just whatever's already selected is fine. But you're going to hit OK. And now you can see I got two different descriptive tables for my two different groups. But the problem is it just has the values for that coded variable, no labels, which is not as helpful. I can go to my data set and my value labels. So my original value labels were remember, if we recoded, it would have been swapped. So that's just kind of confusing. It really helps to have it labeled as male and female in your output, because that's what's going to be most helpful to you. You don't want to have this output and then have to remind yourself, have to go back to your notes or your survey or whatever it may be to remind yourself, or even hand label. Some people print off their output and then just write. It would be so much easier if SPSS already had the correct label here for you. So I'm going to show you. So if we want to go to data and split file, so say I could just reset this. And if I reset this, that's just turning the split file off. So we can see that in our output. But what I'm really interested in is instead splitting the file. So again, organize output by groups based on our original gender variable, just to show you what it would look like if we had the appropriate value labels already in SPSS for us. So I'm gonna hit OK. So now we've split the file by our original gender variable, so you can see that in your output. And I'm going to rerun our descriptives. So I'm not changing anything here because I still want the average test score, I still want the sum test score, but the only thing we changed is how we split the file, which was by our original gender variable this time. So now we get our output and it's labeled as male and female. And again, because it's a fabricated data set, it doesn't matter. We recoded our gender variable just to show what it would, show you the process, demonstrate the process of recoding a variable like this, like a grouping variable. So reassigning values. If the data set were real, we would need to swap these, right? Because we recoded our variable so that they were the opposite. But because this was just, the data set we created for the sake of the assignment, I just want to show you what it looks like when you have the appropriate labels on the correct table. So now we have an output table of our descriptives for men, an output table for our descriptives for women. Okay, so moving on to our last step, which is merging. So we've split the file, we have some output that shows that we split the file by our grouping variable gender. So now we want to merge files. So sometimes you might have, an additional data set that has, more cases. So in this case, it would be our students. So more students and their test scores. So if we just have more instances or cases, participants, students, whatever you want to call it, of the same data, so the same variables. Now, keep in mind, we won't have a data set to merge maybe with these added variables, like we just computed these. So ideally, you would have merged files before we're computing new variables. But again, this is just for practice to show you how you merge files. But again, so there are two different examples. So the one I just gave an example of is adding new cases. So new cases where you have data on the same variables. So you have, different students, gender, and their test scores. So you want to add new instances to this data file. We learned in the first assignment we can also copy and paste. But if you have two SPSS files, you can also merge the data. So what you're going to do is go to Data, Merge Files. And again, the option I just discussed was adding cases. So for this one, I'm going to browse my computer for an additional data set. So I created one with new cases, labeled it the same thing with just a 2, so I would know it's the same. Hit OK, continue. And what I did here, so as we can see, this is telling us the variables that are going to be in the new data set. It didn't move these over because there's not a pair that already exists in the data set that I'm merging. So in the file that I'm choosing to add or merge to this file, these variables don't exist, which makes sense since I just created them in this demo. So, but I still want them to be included in the new data set. So I move them over. They just aren't going to have a pair, like a pair in the new data set. So essentially the new cases, these variables should be blank. And that's exactly what we see. So I hit OK, and we still have the data for these variables that we already computed. So I can see that this was done, but now we have new cases added, and we would have to recompute these variables if we wanted the data for these, but not necessary for this assignment. I just want to be able to verify that you know how to merge a file. Another option for merging a file is, instead of adding cases, so say you don't need to add new instances or new participants, new students. Instead, you have a different data set on the same participants, so these same ID numbers, right? So instead, And I'm, for the purpose of this, going to resort our data so that it makes sense. So sort cases, participant ID, ascending. So again, you should submit your data set sorted by the variable that you chose, so not participant ID, just so I can see you know how to sort by a different variable other than ID, since it will automatically be like that. But now, so I have 1 through 20, but say I have data on, in my case, I have data on 1 through 10, or if I had like the full data set 1 through 20, but say I have just different variables to add. So I collected different data on the same participants that I want to merge with this file. So what I would do is, again, go to data, merge files, add variables. Again, I'm going to browse. This was from our last assignment, but I essentially imported different variables on the same participants from Excel. But I know that I have cases 1 through 10 at least, and I have unique variables. So variables, not test score. I think we had like GPA, major, something like that. So I'm going to choose this one, continue. When we go to add variables, the reason I resorted was because I'm going to go with this default option. So one-to-one merge based on file order. So basically it's going, whoever's 1 in row 1 here should be row 1 in the other data set as well. The reason I'm doing this is because I know in this other data set that I'm bringing in, they are not labeled the same. I can't move ID into our key variables so that it matches up. 1 is 1, 2 is 2, 3 is 3, like so that data lines up with the import. I know that in my other data set that I'm bringing in, I think ID is labeled like student ID. So it's not labeled ID. So I could go into the other data set and change that really quickly, but I'm just letting you know that this is important. So you can merge based on key values and then have your ID as the key variable so that case 1 is matched up in both data sets when they're merged, if that makes sense. So right now I'm just doing it based on file order. That's why I resorted, because I know in this other data set my ID variable is labeled as student ID. So the names of the variables do not match up in order for them to be key variables. So I'm going to get a lot of errors here because it's saying I can't use the key values, right? So I'm going to hit OK. And here I have it lined up. So we can see, because I resorted it, it is lined up. So see, I was right. It says student ID. So it just brought that variable over. So I could get rid of this since it lines up with over here. And again, if I had gone into this other data set and just edited the variable name, I could have used it as my key variable so that it basically would just import these values matched up by ID number. But since I didn't do that, it brought in all of it. And so now I have added variables, at least on the first 10 cases. So now I have their age, I have their major, and I have their GPA, along with their test scores, average, like all of that. So that's really helpful. And that's a case where we might have additional data, additional variables in another data set that we want to merge over. But again, I showed you one way, which is basically merging the file based on order. But if you have your data set sorted by a different variable, like test or any of the test variables, any of the other variables, your ID numbers won't be in order, and therefore that won't work. So you would want to make sure that in your second data set that you're merging, these ID variables are titled they're named the exact same thing. So just ID, ID. And then you can use that merge by key variables. You just have to be sure you identify ID as your key variable. Now that we've walked through the assignment together and I've given you some different options for completing the exercises that I've outlined for this assignment, now just a refresher of what to submit. So as a reminder, there's nothing from lesson 12 that is traceable in your dataset or output files, so that's just practice. Lessons 13, 14, and 15 are what I'm able to verify through the various files that you're going to upload. So I outlined 3. So your working data set that has your recoded, computed, and sorted and ranked variables. So I need to be able to see that you sorted by a different variable other than ID. So if you submit your data set that has ID ranked in order, you're not going to get points for the portion that you sort cases. So the portion of the assignment that tells you to sort cases, I think it's about 2 points. If it's just sorted by ID, the data sets already, when we created the data sets and we were working with them from the first assignment, they're already sorted in order of ID. So I don't want your data set for this first one to be sorted by ID. Sort by a different variable. So by one of your test scores, even one of your computed variables. I don't care, just sort by a different variable other than ID so that I can verify that you did that. And then it'll show, like I said, all of your computed variables, so I'll be able to see you recoded into a different variable. I'll be able to see if you computed a new variable, so either an average test score or a sum test score, and then I'll be able to see that you did a rank variable for your test scores. So those are the things I should see in the first data set. Like I said, be sure you sort by a different variable other than ID. Otherwise, it's not evident to me, unless it's somewhere in your output. If it's included in your output, then that works too. But I want to be able to see your data set that has a different variable used for sorting, whether it's ascending or descending. Okay? And then your second data set, your second data file that you upload is going to show me the merged file. So that's where you're going to show me either you merged by adding variables or adding cases. So you don't have to do both, but you need to do one of them. And so in your merged file, you don't need to show these computed variables. If they're there and they just have blanks like I do, that's fine. But I'm just saying for your merged file, the biggest thing, the takeaway for me is being able to see that you are either able to merge a file by adding cases or adding variables. If you merge the file by adding variables, just keep in mind that you may have to resort your data by ID if you have a data set that doesn't have the ID variable labeled the same exact way. So it should be ID and ID. And if you have both of those labeled the exact same thing, then you can merge the file using the key variable. For me, if you remember, I have to merge the file by file order. In that case, I had to resort this so that it was 1 through 10. So that's why I say just submit 2 different data files, just so I can see the working data file where you resorted a different variable so that it's not in ascending order of cases, it's in ascending or descending order of a different variable, whatever that may be. And then there's a file that shows me you know how to merge files, either by adding variables or adding cases. And I really just recommend you, similar to how we did this first data set that had, the initial 5 variables with 10 cases, do the same thing, except, do cases 11 through 20, or do additional variables for those first 10 cases. Whatever makes sense to you or whatever you prefer, that's fine. You just have to be able to do one of them and submit that merged file. And finally, the last thing you're going to submit is your output file from the entire assignment. And here I'll be able to, verify that you did the split file and you had output. So these just minor descriptive analyses, which I showed you how to run, that are broken up by the variable that we split the file by, gender. So we have a grouping variable that split our output. And I'll also be able to see rank, and even these different commands that you run, will be able to verify through your output. This assignment will be due September 27th, so not this coming Saturday, but the following. So similar to the first assignment, you'll have roughly 2 weeks to complete it. Be sure to reach out if you have questions. You guys did a great job for this last assignment, reaching out with your questions and letting me help troubleshoot if you were having issues. Some of you may have noticed that, like, my tutorial, even though I'm going click by click showing what's happening, different versions of SPSS will also look slightly different or yield slightly different output or something like that. So that's totally normal, but I appreciate you guys reaching out just to make sure what you're doing is correct, or if you're stuck. Or you can also come to office hours. I hold them every Tuesday and Thursday from 4 to 5 p.m. on Zoom. My Zoom link is in the syllabus if you need to talk through or troubleshoot anything. I think most students, when they've reached out and they need to troubleshoot something, I'm able to get a good enough grasp to help over email. But if it's really not clicking for you, or SPSS looks vastly different on your end, then I highly recommend that you come to office hours and maybe we can work through it together. But other than that, good luck on the assignment, and reach out if you have any questions.